Okay, now we're going to start on the lymphatic system. Let me get my pointer ready. Sorry. Okay, so the lymphatic system, this is a very, very, very important system, and probably one of the most important systems in your body. And the reason is because at the cellular level, say that these are just cells. At the cellular level, the extracellular fluid out here has to be just the right amount. If there's too much fluid and it comes out here, okay, what happens is that the nearest capillary, when say potassium comes out here or an amino acid or something, it's too large a distance for that to diffuse through to get to the cell. Diffusion is an attraction between, it's a movement of small particles from an area of high concentration to low concentration, but it's over a limited area. So what happens is these cells start dying, and the lymphatic system's job is to take this extra fluid into its own capillary system, right? It sucks it right in and takes it back into the venous circulation. So these cells need to be in a what we call a relatively dry state. And that just means it's a limited volume of fluid around the cell. The intercellular fluid is at an optimum level. That's called the dry state. Other than that, it'll be wet. And if it's wet, what happens if something is wet and dark and danky? Well, it's a beautiful breeding area for anything. Okay, so then you get disease. So we want to maintain our dry state, and we use the lymphatic system to accomplish that. So the function is to return this excess waste tissue fluid into the vascular system or into the veins. Okay, so the lymphatic vessels collect this tissue fluid, and lymph is simply extracellular fluid, which was once plasma, which was once blood. The name of all the fluids in your body depend upon which compartment they're in. So if they're in an aorta, then it's called blood. If it's outside a capillary, it's called intracellular fluid. If it's in a lymphatic vessel, it's called lymph. It's all the same fluid. Okay, it just has different constituents in it. So in a capillary bed, as the plasma is being pushed out or diffused out, you get a relatively larger volume of extracellular fluid in the capillary bed, right? And the cells, take what they need, but if there's extra pressure there or extra fluid, it'll enter the lymphatic capillaries, and now it's called lymph. And lymph is pretty devoid of oxygen and nutrients, and it's high in waste products, right? So it'll be similar to the contents of venous blood without the cells. So here's what it looks like. We have a capillary bed here. Here's the inflow. Here's our thoroughfare right here. Here's the capillary bed. So a lymphatic vessel is blind-ended. If you look over here, this is blind-ended, okay? It doesn't run through a capillary bed. It has these blind ends right here, okay? And it's simply picking up fluid from this capillary bed, and it's going to go back through a chain of, see, here's a kind of a schematic. These smaller capillaries will join into lymphatic vessels. They're going to run through these lymph nodes and be checked out for pathogens and other foreign bodies that shouldn't be there. And then it's going to return into the venous blood right before the heart. So again, lymphatic capillaries are blind-ended, and they originate on the venous side, mostly on the venous side, but you can see they're over here as well. They're in the capillary bed. The vessels, these vessels here, are very thin walled. Thin walls, um, one layer of endothelium. And we have these little filaments here, and they sort of anchor into the tissues so they don't move around. Everything in your body sort of has to be anchored. Then we have these little flap-like mini valves here, and this is where the fluid will enter. Okay, so the extracellular fluid out here, whoops, extracellular fluid, is now lymph right in here. So that's how that goes. The interstitial fluid is defined as a fluid which was first plasma but has left the capillary and is now surrounding cells. Now you may have heard intercellular fluid. This is also fluid that is between cells. I think technically the intercellular fluid is the fluid that's closest to the cell, and extracellular fluid is a little bit farther out. That's just a very, very technical term. You can use these interchangeably. Okay, so yeah, we have fibroblasts out here in the tissue. It doesn't have any relationship to this. I think that does it for this one. So the lymphatic system, they consider it part of the immune system because it scans all the lymph for pathogens. And it does protect our bodies from foreign organisms that have already gone into the blood and into the tissues, right? Because it's being picked up from capillary beds. It comes face to face with disease, so they say it confers immunity. So, if you have a bad guy, here's a bad guy, and then you have your lymphatic system here, it will pick up this bad guy, right? It'll go to a lymph node here, and in the lymph node, it'll break that bad guy up and eat him. So then you're immune to that disease because the lymph node took care of it. All right. So here are the main components. This will be an answer to one of your questions. Lymph, that's the fluid. Lymphocytes, remember that's one of those white blood cells. Lymphoid tissue, these are patches of lymphocytes in loose connective tissue. And then lymphoid organs such as the thymus, the spleen, and tonsils and lymph nodes. So we collect excess tissue and blood proteins and return them to the bloodstream. We know that. So the lymphatic capillaries are the smallest ones. They receive the lymph. They're very permeable, of course. Then we have, lymph capillaries. This is the beginning of lymphatic system. Then we have collecting lymphatic vessels. This is just, here's a capillary bed. Here are all the lymphatic capillaries. Those will join, form a collecting lymphatic vessel. And then we have lymph nodes here. Lymph node. So we have, a lot of lymph nodes that this fluid goes through. Then we have a lymphatic trunk. That's the third vessel. And then a lymphatic duct. And these are the ones that empty into the subclavian veins. So the capillaries, they're wherever capillaries are in your body. And whenever there's too much extracellular fluid, that's going to be pushed right into the capillary. And these mini valves open up and allow that fluid just to pop right in. In there's going to be, of course, the fluid. There will be protein molecules. There may be bacteria, virus, cancer cells, just to name a few. Now, you need to know lacteals. These are very specialized lymphatic capillaries, and they're located in the villi of the small intestine. And a villi, in the intestine, we have a layer. Okay, if this is the lumen here, we have a layer on each side of simple, probably, what do I want to say? Columnar. Okay, and these have villi on them, extensions, right? Some of these will have what's called a lacteal, and these will ingest digested fats, and fatty lymph is called chyle. And that'll take that to the liver and it'll be handled there. So just know that a lacteal is a special um, tissue that takes the fat, digested fat, from the lumen of the small intestine in these villi and returns it to the liver as everything that's ingested in the small intestine. And they have more valves than veins do, okay? Which help, of course, direct the flow of blood upwards. So the flow of lymph is not aided by the heartbeat, nor is it in the veins. Lymph is propelled by three weaker mechanisms. You need to know these. 1. Skeletal muscle contraction. 2. Pulsing of nearby arteries. And 3. The tunica media of the lymphatic vessel, which is slightly elastic. And there may be some smooth muscle, but it's very little. In adults, the duct is typically 45 centimeters in length, so about here to here. Thoracic duct is one of the main trunks that return. Average diameter of 5 millimeters. That's like two nickels and a dime, the edgewise. The vessel starts from the level of the second lumbar vertebrae down here, and then goes up to the root of the neck up here. The root of the neck is this area here. So a drop of lymph will enter a lymphatic capillary, travel the same course as the accompanying vein until it empties into the nearest lymphatic, which will travel into a vessel and through one. Once it leaves a node, the vessel will join either the lumbar, intestinal, bronchiomediastinal, subclavian, or jugular, which will either be the thoracic duct or the right lymphatic duct. So here's our internal jugular. So here's a lymph node, and what happens is that these collecting vessels, will enter these afferent channels. It has a lot of afferent channels, right? So lymph is coming in. Then you have these areas in a lymph node, and what happens here is that the lymph will fill these areas, and it'll mill around all of these areas here. These are centers where B cells will proliferate in all of these centers here, and these are called germinal centers of a lymphoid follicle. Okay? So B cells are going to be living there, they're nurtured there, and their job as this fluid lymph, mills around them is to scan this lymph for things that B cells can identify. Out here, hang on, here, the subcapsular sinus, so around here, these are where T cells will proliferate. Okay? T cells. They look for different type of pathogens. Now B cells are going to be looking for things, viruses like mumps, measles, chickenpox, things like that. And the T cells like cancer cells, things like that. And in here we have macrophages. This area is called the medulla, and these things are called medullary cords, and this is where macrophages congregate. So I'll ask you, where are the T cells in a node, where are the B cells in a node, and where are the macrophages in a node? So the B cells are out here, the T cells are here, and the macrophages are here. And as a lymph, it's coming in all of these different channels, and they're right around a lymphoid follicle. So the fluid's going to go around here and be exposed to the B cells here and the T cells in here, and then they have to pass through this cortex or this medulla in here, and they're going to pass by all these macrophages, which are just going to pick up anything that is not a cell is going to be picked up here. Any fragments of cells, any dead cells, any bacteria that manages to get through. And then we have our efferent channels coming away. So it's pretty simple if you just think about it. Just think about it for 5 minutes. I want to know that you understand the flow. This is going to come in, flow around here, and then go out one of these channels. Right, here's flow. It's all going to flow in here. So you have all of these coming in, but just two going out. So it's going to build up pressure, which you want. It's going to create more flow in here. You want things to flow through here. Now, when you have an infection in a lymph node, then you have an inflammatory response and an infection, and then they're going to swell up because they just can't handle the load. Then some of it will escape and go to the next lymph node, then those will swell up, etc., etc. Okay. So all of these things in here, these are called trabeculae, just so you know. Each of these follicles here has a channel that comes into it. Okay. So the trabeculae just divide these up, so it will push this fluid in. It's not like it's from one to the next, and it doesn't have to. And then go out. Here's the convex. The afferent, those will be the afferent. The lymph exits at the hilum organ, and a lymph node is an organ that has things going in and out, is called a hilum. So where the blood vessels will go in and out of the lungs, is the same place that the bronchioles go in and out of the lungs. That'll be the hilum of the lungs. So lungs have, what do you call them? Kidneys have a hilum. Lymph nodes have a hilum. And if I think of any more, I'll let you know. And this is what it looks like microscopically. So we're going to go into the lymphatic trunks. So the collecting lymphatics converge to form trunks. The 5 major trunks, the lumbars, intestinal, bronchiomediastinal, subclavian, and jugular trunks. I'd like you to know what each of these drains. So the lumbar trunks, lower limbs, intestinal trunk, digestive organs, bronchiomediastinal, thoracic viscera. It all makes sense. I mean, if I put that in a matching, that's pretty easy. The subclavian trunks, upper limbs and thoracic wall, and the jugular from the head and neck. This is sort of what it looks like. So you have the right jugular trunk here, the right lymphatic duct here. That's going to go right into the right subclavian. Here's our jugulars here, veins, or jugular veins, left and right subclavian, inferior vena cava. Superior vena cava. So the heart's here. Then we have, here's your esophagus and trachea. Here's the left jugular trunk, left subclavian trunk, and those are going to go right into the left subclavian vein and be returned to the heart. These are the mediastinal trunks. Here's the thoracic duct. Here's the cisterna chyli. Here's the lumbar trunk, left and right, inferior vena cava, and here's the intestinal trunk right here. Okay, it's not that big a deal. Here it is on a cadaver. Ours aren't dissected down that far. I wish we were so we could see these. So the cisterna, it's an angi, what do you call it? Where it just poofs out. If you can look at it, see if we have one here. Cisterna chyli is right here. Oh, it doesn't even show that well here. But it's this, okay? As you see, it's just because all of these drain, this gets a little bit larger. So infectious organisms trigger an inflammatory response first. That's kind of the first line of defense after the skin. Okay? Very simple. Now here's what happens. If you have all of your body cells have markers all over them, but one of these markers is called an MHC marker and it has a very specific shape and charge. And your immune system, here's a cell of your immune system, it comes along and it has the reverse um, signature on it, molecule, whatever, on its um, cell wall, and it will match it, meaning it's identifying it. If it, we could go like this, and then this one would have something like, so that would fit right into that, right? Because the shapes match and the charges match. If you have a plus and a minus, that's a nice fit. Okay? So that means it's recognizing this MHC marker, and this MHC marker is specific for each person. This is a Jackie MHC marker. So these attack foreign cells directly. These are like snipers. S-N-I-P-E-R-S. Snipers can only kill one person at a time, right? They have one rifle, they have a target, and they kill it. They bind to the antigen bearing cells because they have a molecule on them. They perforate the cell membrane. So this is the intestine, and this is how the intestine. This is just lymphoid tissues, and here's a lymphoid follicle. So sorry, I just needed a drink. Okay. So the primary lymphoid organs are the bone marrow and the thymus, because these are the nurseries for these um, lymphoid tissues or cells. Secondary ones are the lymph nodes, spleen, tonsils. So they're sort of born and stored here, then they go out to these places here, and then they do their jobs. And they're in very significant positions in the body. These used to be called Peyer's patches, now they're aggregated lymphoid nodules. Here's the appendix. They stand like sentries, and they're where they will be subjected to these pathogens. Okay, the thymus. This is where the immature lymphocytes develop into T lymphocytes as a youngster. By the time you're 7, this is no longer even active, and by the time you're 25, you don't even have a thymus anymore. When you're young, you get thymic hormones, but we don't even talk about that. Atrophies with age. Like I said, by the time you're 25, there's nothing left of it. It has a cortex and a medulla, but I'm not going to ask you anything. I just want you to know that that's where the T lymphocytes come from. It's just underneath your sternum. Lymph nodes, again, lymph percolates through the lymph nodes, and it's exposing the lymph to the T and B lymphocytes and the macrophages. The spleen is the largest lymphoid organ. It's filled with blood, and it has a blood cleansing function as well as a lymphatic function. Again, it will identify antigens and remove them, and it also removes old blood cells and broken blood cells. It's also a site of hematopoiesis in fetus. That means origin of blood cells in a fetus. B cell maturation is in the spleen. Phagocytosis eats up the worn out red blood cells, white blood cells, platelets, and it also stores platelets. So if you have a platelet disorder, they always look at your spleen to make sure that's functioning. There's white pulp, which is thick sleeves of lymphoid tissue. Antigens are destroyed as they activate the immune system, provides immune function in the spleen, and then the red pulp is for the blood deposition, or the part that takes care of the red blood cells that are worn out. There's the spleen, more about the spleen. I don't need you to know anything about the spleen's inner anatomy, okay? Just that the red pulp is for the blood, and the white pulp is for the immune. That's all I need you to know there. There's what it looks like. Okay, tonsils. This is a lymphoid organ, sort of. There are 4 groups: the palatine, lingual, pharyngeal, and tubal. They're arranged in a ring, and they're at the back of your throat. This is macrophage. What is again? Let me hang on. So these are the locations of those tonsils. I just want you to know that you have tonsils. Yeah, these are aggravated lymphoid tissues. They fight bacteria, generate memory lymphocytes, which are very important. We have aggregated lymphoid nodules. These are Peyer's patches in your intestines, your small intestine. Your appendix is a tubular offshoot of the cecum. They actually don't know what that's for. They do find some lymphoid cells in there, so they think that, but it's also filled with bacteria, the friendly bacteria. So they think that sometimes if your bacteria gets wiped out in your intestines, that it reseeds it from cells in the appendix. I really don't know what the appendix is for. So anyway, MALT is an acronym for this. Okay, it's just lymphoid tissue and lymphoid nodules. These are the Peyer's patches in the intestine. So we can move on to some disorders. Chylothorax. Chylo means lymph tissue, and thorax. So this is leakage of fatty lymph in the thorax. Lymphangitis, that would be inflammation of a lymph vessel. Mono is a viral disease caused by Epstein-Barr, and that attacks B lymphocytes, which can really depress your immune system, and that's why it takes about a year to get over that. Then I'd like you to know Hodgkin's lymphoma, that's cancer of the lymph nodes, and then non-Hodgkin's lymphoma is uncontrolled multiplication and metastasis of undifferentiated lymphocytes. So these are bad conditions, and they usually kill you. Lymphatic system. Just remember that the thymus is very active when you're born, very large, and that will go away by the time you're 25. The thymus originates as an outgrowth of endoderm. You don't need to know that. Everything is from mesodermal mesenchymal. That's the middle layer of the 3 layers of a fetus. Okay, and that's it for that.